We are going to discuss about 3D noise. When I talk about noise, I don't mean this kind of noise, which are bunch of random points. I mean this kind of noise, which is a smooth type of noise and each point is going to change in a smooth and random way. Not in 2 dimension, but instead in 3 dimension. You may ask why I need this kind of noise, and I will tell you the applications of this kind of noise are endless. You can generate a 3D world with it. You can generate a cave system with it. You can use it for force field for particle in 3 dimension. You can use it for fog or any volumetric shader. And this is not just for 3 dimension. Look at the noise at this angle. I just bring this noise into 2 dimension and just move the depth of it. Like this. And I create this effect by that. Well, you can find more application for 3D noise, but let's get to it. So in this video, I'm going to show you 2 methods to generate a 3-dimensional noise. First, we are going to stack 64 noise textures with dimension of 64 by 64 to generate a 3D noise. This method will give you the best result. And for the next method, we are going to use only one 2-dimensional noise texture to generate our 3D noise. And this thing that you are seeing right now is generated with only one 2-dimensional noise. So let's get started. For the first method, we are going to generate this 3D noise texture by code. For that, we use a class in Godot which is called ImageTexture3D. So this is my GD script code. First, I activate tool mode, so my code will run in editor. Then I create a boolean, which when I press that will call generate function, which is going to generate our noise. So now if I click on it, it will going to pre-generate noise on console, and it is working. If you want to follow along with this tutorial, please be aware sometimes when you activate tool mode and you want to write some code, it will not work properly. And the way to make that correct is by restarting Godot editor. And finally, I add another variable which is called noise dimension, which is 64 for now. Godot has a class which can create different type of 2-dimensional noise images, and it is called FastNoiseLite. So I create new instance of this class. And here, because we work with low resolution images, I just increase the noise frequency a little bit. There are a bunch of other settings which you can change to get different type of noise, but for me that is enough. Then I'm going to create an array which all of our layers of image will be inside this. And here I define a for loop for creating these layers. To create a 2-dimensional image, you can call a function inside FastNoiseLite which is called getImage. There is another function which is called getSeamlessImage, which is going to create a seamless image. For now, I choose getImage. First and second argument for this function is the width and height of our noise image. Third argument is if we want to invert the color of this noise. In this case, it is false. And fourth argument is really important, and you should put that to true. And it is telling to generate our noise image in 3 dimension. So this will give us a 2-dimensional image. Now append this image to the image array which we created. This loop is going to generate the same image for all images. And this is the tricky part. Just add 1 to the offset of past noise in Z direction. And now this will move in Z direction for each image. Okay, we created all the images. Now we should create our 3D noise texture. For that, we are going to use ImageTexture3D noise class. Create a new instance of it and call function create in that. So here, first argument of this function is the format of our image. And format of all of image should be same. So here I just grab the format of our image from the first image on our array. You can also write the format manually, but in this way, if I change the format of my noise texture, here also automatically image format will change and it will give us no error. Next 3 arguments are noise texture dimension. And fourth argument is asking if we want to create a MIP map, and in this case I set it to false. And finally we pass the array of image which we have created. Well done, we have created our 3-dimension image. Now to show you how you can use these in shader code, here I created a basic shader code. Here we define a uniform for our 3D texture. And this time we should use sampler3D. Then I define another uniform which is called depth, and this one is going to change the depth of the noise texture. Later I'm going to show you this noise texture also in 3 dimension. But here, because we work with 2 dimension, I define this depth uniform. Now we should read from this noise texture. Please note this time for reading this noise texture, we should provide a vector tree. For the first 2 arguments of this vector tree, I use my UV coordinate, and for the last one, I use depth uniform. Well, here I write a small piece of code which is going to assign this 3D texture which we created to my shader. Now let's generate our 3D texture. And now, if I change my depth variable, I can move inside my 3D space. One important thing is you don't have to stack 64 images on top of each other always. In most cases, with much less texture, that will also work. Because when I change the depth value, this will automatically blend between 2 layers. Now let's take a look at this in 3D space. For that, I created a multi-mesh with a lot of cubes in a 3-dimensional grid, which each cube is going to change its size and color based on our noise value. I'm not going to explain how I created this, I just want to show you how this 3D noise texture looks like in 3D space. So here is our noise 3D in 3D space. I also use a smooth step function on my noise value. For the next method, we are going to use only one noise texture. So as you know, for the previous method, we stack noise texture on top of each other. This time, instead of putting different noise texture on top of each other, we put the same noise texture that we have on top. Well, now we move it. Not this way. I mean, we move its texture coordinate this way. And if our noise is seamless, we don't have a problem. Now for each point in a space, we interpolate between these 2 noise values. I hope up to this point everything was clear. So now what if I want to go up and get a noise value from this point, which is not between these 2 noise textures? To explain that to you, let me show you everything from side view. So this is our 2 noise that we have. And this is the z direction of our 3D noise space. I put the value of the z here to be 0 and here to be 1. So if the z is 0, we just say this is our noise value. And if z is between these 2 planes, we just interpolate between these 2 and give the new noise value. Now what I want to say may confuse you a little bit, but don't worry. You will understand that when we get to code. And now, when the z position is 1, what we are going to do is to set the z value to be 0 again and move the bottom plane texture in the way that is going to be same as the noise texture above. So our noise value would be identical if we would be remain at z equal to 1 position. And we move the texture coordinate of the texture above to create another noise texture. Okay, let's do this in the code. So here I create a simple shader code. I define my sampler3D uniform for noise texture and a float uniform for changing depths. Please set a filter linear for noise texture. Otherwise, sometimes that could cause a problem. Well, first I define a vector2 constant for moving texture coordinate at each layer. Here I use a shader preprocessor which is introduced in Godot 4. If you are in Godot 3, just use a vector2 variable. And if you want to know more about shader preprocessor, I created a video about that and I will put the link of that video in the description. Well, now I define another variable which is called z and I assign depth to it. So here we should define the texture coordinate for each layer and I define them in this way. So take a closer look at these 2 texture coordinates. For example, when the value of the z is above 1, z1 is equal to offset plus uv and z2 is equal to 2 times offset plus UV. And when the value of the Z is above 2, these will be the value for Z1 and Z2. So this will do what we need to do. Now we get two noise value based on our texture coordinate. And done. Now we should grab the blend ratio, and we just do that by grabbing the fraction of the Z. So this will be always between 0 and 1 and will give us the relative Z position between two layers. Now just mix these two noise value with this ratio. And if I set my noise to albedo, we have our noise texture. Then I change my depth and I have this effect. As you can see, by changing the depth, my noise also change. But we can see a sudden movement in our noise. To show you better what is happening, I just modify my code a little bit. I define a UVW, which is a vector tree, and for the first two components of this vector tree, I use my UV coordinate, and for the last component, I use my Z variable. Well, now I just replace everything below by UVW like this. Everything is working like before. Now to see the new noise that we generated, I just exchange the UVW component. So we have a stretch texture. But if we scale our Z by multiplying that to a big number, you can see the noise that we have generated. If you look closely to this noise, you can see a line everywhere we change our layer. So why is like that? Well, that is because we linear interpolate between two noise. This is how linear interpolation look like. As you can see, we have a smooth transition between these points, but as soon as we arrive at the point and we want to continue, we do a break. This kind of noise with this line is also okay for some situation. But here I want to make it better, so I found two solutions for this. And you may find more solution, and if you do, please let me know. I will be happy about that. So the first solution is not to change this ratio in a linear way between 0 and 1. Instead, we are going to change this ratio slowly at the 0 and go up, and finally we slow down again when we arrive at 1. So the math formula that has this character is this. 1 minus cosine x times pi divided by 2. Which x in this case is our ratio. So let's do that in code. And as you can see, those lines is gone and we have a smooth transition. But this method has a drawback, and that is when we move in the Z direction, we can see that the noise is slowed down and speed up. In another word, it not seems a continuous noise. But depend on what you want to make with this 3D noise. This might be okay. So now let's go to the next method. For the next method, I just create another texture noise on top of my other texture noise. And I have two mix value. One between the first noise and second noise, and one other between second and third one. Now I mix between these two values with ratio of 0.5. And that will give me this result. So this noise is continuous and move at the same speed as you can see. But it is more process costly because we read another time from our noise texture. And this is the noise that I created with the cosine interpolation in 3D space. And this is the noise that I created with 3 noise textures in 3D space. I hope you use 3-dimensional noise for creating some cool effect. And if you do, I will happy to see them. You can even go further and create a 4-dimensional noise. We have also 4-dimensional noise. But that is enough for this video. If you have any question or suggestion, let me know. Until the next video, bye.